All right, we're going to look at the area of kites, rhombuses or rhombi, and trapezoids today. All right, the area formula for a kite or a rhombus is area equals 1/2 diagonal 1 times diagonal 2. So you'll have to have the entire length of the diagonals, and in some cases you'll have to use Pythagorean theorem, because if you recall, the diagonals of a kite and a rhombus intersect at 90 degrees. So you have a right triangle for all four of the triangles that are created. Okay, so that might come into play depending, but if it doesn't come into play and you do have the lengths of your diagonals, it's very straightforward. You just take them and add up your diagonal all together, all your pieces. So this piece is 3 plus 3, so it's half of 6, because that's the first diagonal, times the second diagonal length, which is 2 plus 4, which is 6. Again, that's coincidental. So the area equals to half of 36, or if you took cross-canceling, 2 into 6 is 3, and you're going to get 18 either way. Now, if you don't have a unit, get into the habit of putting a units squared. Okay? If you do have a unit, use the unit properly and don't forget to square it, because it is area. All right, next is looking at the area of a rhombus. Okay, as you recall, as I said before, the rhombus diagonals meet at 90-degree angles. So we have this part here, which is 8, and since a rhombus has all four sides equal, this is 10 inches. Okay, so we have a unit here, which is good, so we'll be using that. But since we have a nice right triangle here, we're going to have to find out what the side is. So this is 10, this is 8. And you may recall that there are 3, 4, 5 right triangles, and any multiples of those are also valid Pythagorean theorem triples, or Pythagorean triples. So this is 6. But if you did not remember that, make this a, because you don't know it, or x. So I'm going to make it a squared plus 8 squared equals 110 squared. So I'm going to get a squared plus 64 equals a 100. If I take away 64 on both sides, I'm going to get a squared equals 36. Again, taking the square root of both sides, including positive and negative results for the a equals to positive -6, but we only want the positive because it is a length. So in this case, you would get back your 6. So we'll put that on our diagram here, 6 inches. And now we want to find the area of the rhombus. Area of a rhombus is half of one diagonal times the other diagonal. All right, well, this piece of the diagonal across here is 8 inches, so the other side has to be 8 inches. So I'm going to write that on there. That gives me 16. So the first diagonal is 16. The other diagonal that I used to get the 6 from for this length here is this is also 6, because you remember that the properties of a rhombus, the diagonals bisect each other and they meet at 90 degrees. So this is 12. Half of 12 is 6. 6 times 16 is 6 times 16. Half of 12 is 6. 6 times 16. It's going to be 96, I believe. Or you could do half of 16 and get 8, and 12 times 8 is 96. Because we do have a unit here of inches, you write inches squared, or you can put in squared. And that's how you find the area of a rhombus. And in this case, we had a little bit of work to do to get the length that we needed for the diagonals. All right, now let's explore our trapezoids again. In class, we talked about trapezoid and the formula, and it's not that you have to remember anything really hard about the formula for the area of a trapezoid, but remember, trapezoid is closely related to a triangle. A triangle has a base, a triangle has a height, and it meets it's an altitude, or it meets at 90-degree angle on the other side. But a triangle, when you take off its top, when you cut it off at the top, turns into a trapezoid. So if you look at that, we just took off the top of the triangle. So what happens now is we don't just have one base, we have 2 bases. Because you can sit on the longer base, or you can flip it upside down and sit on the shorter base. So there's 2 bases in a trapezoid. So the area of a triangle is half base height. The area of a trapezoid is also half base height, but in this case we have two bases, so we add them up and we times by height. All right, so keeping that in mind, I'll move that over there. We have a trapezoid that has a base of 38 all the way across. If it was only from here to here, it would be 21, just like this. Or actually, it may not be. It depends if it's a right trapezoid or not. Or you'll have lines indicating where that 38 goes. But since it doesn't have any indicator of where it is the whole length. 21 is the top base, and our height is 16 inches. Okay? So area equals half of our bases added together times our height. So area equals half of our first base is 21, our second one is 38, or vice versa, times 16. Okay, so area equals half of 21 plus 38 is 59, times 16. You could take half of 16, which is 8, and 8 times 59 is 472, or you could just take half times 59 times 16 in a calculator, and you'll get 472. And since we do have a unit here, inches, it's inches squared. And that's how you find the area of a trapezoid. All right, now, sometimes you will be given a little bit of a challenge, like this problem right here. Okay, instead of doing this in pieces, piecemeal, okay, trying to find the area of a rectangle, area of a triangle, and adding them together, look at the big figure. It is a trapezoid. It is a right trapezoid. So we have some information here that we can use. From here to here, okay, is 9 feet, which means that this is 9 feet. What we need to do is we need to find this length here of the triangle, and we need to find its height. So we'll call that h. And we'll call this just x, okay? Now, what you notice is that this is coming down at 90 degrees because this is a nice rectangle. So if we have 90 degrees here, this is the 30, 60, 90 right triangle. So you can use your rules for 30, 60, 90 right triangles to find this piece of the base of the whole trapezoid and the height of the entire trapezoid. And it could be quick. All right, so in a 30, 60, 90 right triangle, you need the short side to find any of the other sides. Well, we have the hypotenuse, and if you recall, the hypotenuse equals 2 times the short leg. We don't know the short leg, but the hypotenuse is 8. So 2 times x would give us that rule. 8 is connected to our short leg, which actually is h, I'm sorry, our height, which is our short leg, by 2, timesing by 2. So if we divide and divide, we get h is equal to 4. Okay? So now we have the height. So now from here, opposite the 60-degree angle is the long leg, and we know that we take 4, which is our short leg, times root 3, and we'll get our long leg. Okay, now comes the tricky part. This whole length from here to here of our trapezoid base is now 4 root 3 plus 9. Can't add these together because of the square root on with this 4. So 4 root 3 plus 9 is the actual length, and this is in feet. And I usually enclose that in parens. That way I can differentiate that this whole unit together, that whole thing, is the length. All right, now we need to do some work. All right, and we're going to take a look at how to calculate our area. Okay, so area of a trapezoid is half base 1 plus base 2 times our height. So area of a trapezoid equals half. Our first base is 9, and the other base is 4 radical 3 plus 9. All right, and then our height is 4. Okay, so let's work inside here first. Order of operations says work the inside parentheses. So 9 plus 9 is 18, plus 4 radical 3, and that's as far as you can take it. And then we're timesing by 4. You can cross cancel if you wanted to. Half of 4 is 2. And then distribute that 2 into 18 and to the 4 root 3. And that's going to be 36 plus 8 root 3. And this is in feet, so it's feet squared. And again, I usually enclose these in parentheses. That way you know that the entire length is, or the entire thing is the area, okay? And don't forget you squared on the feet. Now, if you want to take a calculator, you can take 36 plus 8 root 3 and put it in your calculator. If it gives you back the same answer in this exact form, hit that little double arrows above your enter key and it will toggle it into a decimal form. And it comes out to approximately, and use your squiggly equal signs, to 49.856. So we will approximate it to the nearest hundredth, which would be 49.86 feet squared. And that is your area of this trapezoid without doing it in pieces. So this is how you find the areas of kites. It's half diagonal 1 times diagonal 2. Rhombus, again, the area is half diagonal 1 times diagonal 2. And trapezoids, where it's the same as a triangle, but you have 2 bases. So the area is half of the 2 bases added up, or the sum of the bases, times the height.